NFPA 96, the standard for ventilation control and fire protection of commercial cooking operations, addresses lighting within exhaust hoods. Section 11.3.2.3 specifically states that all lighting within the exhaust hood must be turned off during a fire, irrespective of its location. The rationale behind this requirement is threefold. Firstly, to prevent the spread of flames and smoke to other areas of the building. Secondly, to avoid the formation of toxic gases from burning electrical components. And thirdly, to provide firefighters with better visibility during firefighting operations. This means that all lights physically situated within the confines of the hood, regardless of wiring or component placement, are subject to this regulation. There are exceptions. Firstly, emergency lighting is permitted if it is specifically designed to remain operational during a fire. Secondly, lighting that is an integral part of a fire detection or suppression system is also permitted to remain operational. This allows for systems that automatically activate lights to aid in suppression or evacuation efforts. In the described scenario, the location of the electrical metallic tubing, abbreviated EMT, and electrical boxes becomes significant. If the EMT and boxes for the lights in the old section of the hood are mounted under the hood, the lights they supply must be turned off during a fire to comply with NFPA 96. The concern is that the exposed wiring and components could contribute to the fire or create hazardous conditions. Conversely, if the EMT and boxes for the lights in the new section are mounted on top of the hood, with only the lights themselves located under the hood, the lights can remain on. This is because the critical electrical components are considered to be outside the immediate fire zone. It's recommended that the control panel be modified to ensure that all lighting within the exhaust hood is turned off during a fire. This may involve adding additional relays or control circuits to disconnect power to the appropriate lighting fixtures. Secondly, it's important to verify that the lights in the old section of the hood are not inadvertently connected to the emergency lighting system. Connecting them to the emergency system would violate the intent of NFPA 96. To elaborate further on the importance of these regulations, consider the potential hazards associated with electrical components in a fire environment. Electrical wiring, insulation, and other components can rapidly degrade and ignite when exposed to high temperatures. Burning electrical components can release toxic fumes, including chlorine gas, phosgene, and dioxins, which can pose a serious threat to firefighters and building occupants. Moreover, the presence of energized electrical equipment can create an electrocution hazard for firefighters who may be using water or other conductive agents to extinguish the fire. By requiring the shutoff of lighting within the hood, NFPA 96 aims to minimize these risks. The enhanced visibility for firefighters is another crucial aspect. Smoke and flames can quickly obscure the interior of a commercial kitchen, making it difficult for firefighters to locate and suppress the fire. By eliminating unnecessary lighting, firefighters can better see through the smoke and identify the source of the fire. The exceptions for emergency lighting and fire detection/suppression lighting are carefully considered. Emergency lighting is designed to provide illumination for evacuation purposes and must be constructed to withstand fire conditions. Similarly, lighting that is part of a fire detection or suppression system is essential for the proper functioning of those systems and must be designed to remain operational during a fire. It is imperative to consult the full text of NFPA 96 for complete and accurate information. This standard is regularly updated to reflect the latest fire safety practices and technologies. Local codes and regulations may also impose additional requirements. Therefore, it is always advisable to consult with a qualified fire protection engineer or code official to ensure compliance with all applicable regulations. Now let's delve deeper into the technical aspects of implementing these requirements. Firstly, the control panel modification may involve the installation of a shunt trip breaker. A shunt trip breaker is a type of circuit breaker that can be remotely tripped by applying a voltage signal to a shunt trip coil. This allows the ANSL system to automatically de-energize the lighting circuits when the fire suppression system is activated. Secondly, the wiring for the lighting circuit should be installed in accordance with the National Electrical Code, specifically Article 300. Article 300 provides general requirements for wiring methods and materials, including provisions for protecting wiring from physical damage and environmental conditions. When installing wiring in a commercial kitchen environment, it is important to use materials that are resistant to grease, moisture, and high temperatures. Thirdly, the lighting fixtures themselves should be listed and labeled for use in commercial cooking environments. These fixtures are typically designed to withstand high temperatures and are constructed with materials that are resistant to grease and moisture. The specific requirements for lighting fixtures are outlined in UL 1598, the standard for luminaires. In addition to the technical requirements, it is also important to consider the human factors aspects of these regulations. The lighting within a commercial kitchen should be designed to provide adequate illumination for workers to safely and efficiently perform their tasks. However, it is also important to avoid glare and excessive brightness, which can cause eye strain and fatigue. The Illuminating Engineering Society, abbreviated IES, provides recommendations for lighting levels in various types of commercial spaces, including kitchens. Proper maintenance of the lighting system is also essential. Lighting fixtures should be regularly cleaned to remove grease and dirt, which can reduce light output and increase the risk of fire. Burned out lamps should be replaced promptly to maintain adequate illumination levels. Furthermore, it is crucial to train kitchen staff on the proper procedures for operating the fire suppression system and the emergency lighting system. Staff should know how to activate the fire suppression system in the event of a fire and how to evacuate the kitchen safely. Regular fire drills can help to reinforce these procedures. To summarize, NFPA 96 requires that all lighting within a commercial kitchen exhaust be turned off during a fire, with exceptions for emergency lighting and fire detection/suppression lighting. This requirement is intended to prevent the spread of fire, reduce the formation of toxic gases, and improve firefighter visibility. Compliance with these regulations is essential for ensuring the safety of building occupants and firefighters. The implementation of these requirements involves a combination of technical considerations, including the selection of appropriate electrical components and wiring methods, and human factors considerations, including the design of the lighting system and the training of kitchen staff. It is always advisable to consult with qualified professionals to ensure compliance with all applicable codes and regulations. Remember that fire safety is a shared responsibility. By working together, we can create a safer environment for everyone.